All right, guys, we're going to carry on into 3.2 today. We're going to look at integers and what they are. We're going to graph integers on a simple number line. We're going to use our less than, greater than symbols. We're going to talk about absolute value. We're going to perform operations and look at our order of operations. Nice thing about a lot of this stuff, our calculator will help us through. But those are the things we are going to do today. All right, so what are integers? We talked about the natural numbers, which are the numbers you count with. We didn't really talk about, but the whole numbers are, if you remember, the same as the counting numbers, except they include zero. Integers are when we start talking about negative numbers also. So the integers are all the negative numbers, zero, and all the positive numbers. Not talking about any decimals or fractions now. These are all whole numbers that are positive or negative. All right. Notice they say you can use a positive sign to represent a positive number, but we don't ever do that. If it's a positive, we just don't put a number, anything in front of it. Then obviously, if it's a negative number, we put the minus sign in front of that. I believe we've all got that. All right, so we are talking today, when we're talking about graphing, is talking about graphing on a number line, not the coordinate axis, just a single number line. And when we draw a standard number line, we just draw a line, arrows on both sides, meaning it keeps going forever. We generally put zero in the middle. Positive numbers always go to the right. Negative numbers go to the left. So the further you go right, the bigger the number. Bigger. I need to put a pencil. Bigger. As you go to the left, the numbers get smaller. Always. All right. Zero, one thing to note, is neither positive nor negative. It splits it up. So zero is sort of in between the positives and the negatives. It's not considered a positive or nor a negative number. All right, so if we want to graph on a number line, very easy. I think we all have this. We draw the number line. -3, we just go to -3 and put a dot. Go to 4, put a dot. Go to 0, put a dot. That's how we graph on a number line. All right, quickly move through that. Not difficult at all. This goes along right while we were saying, as you go to the left, numbers get smaller, numbers get bigger as you go to the right. So if we have two numbers graphed on a number line, the one that's further right is larger. The one that's further left is smaller. Okay. So we know here -4 is less than -1. So we're just introducing our inequalities here. This is our less than symbol. Some people tend to get, or some people have trouble remembering which one's less than, which one's greater than. But we read from left to right. So as you go from left to right, if you come to the small end first, it is less than. This number over here is smaller or less than the next number. Okay. So it always points to the smaller number, though, regardless of what order it is in, because we don't necessarily have to write the smaller number on the left. So this one is a greater than symbol because -1 is larger than -4. All right. But the thing you have to remember is it always points towards the smaller, right? The smaller side is closer to the number that's smaller. All right. So if you wanted to insert here, it's very simple when one's negative, one's positive, because we always know the negative number is smaller than the positive number, right? So we're pointing at the -4. Now, when they're both negative, it's the one that's more negative is smaller, right? So -5 is more negative than -1, so it's smaller. -5 is more negative than -2, so it is smaller. And all negative numbers are smaller than 0, so here we go. Okay. Shouldn't have any issues with that. Moving quickly. All right, now remember this, whenever we put the little line underneath, and we're comparing things, that means that it could be less than or equal to be true. This one would be greater than or equal to. Okay? So notice now both of these statements are true. 2 is less than or equal to 9. That's true because 2 is less than 9. 9 is less than or equal to 9 because 9 equals 9. That is now a true statement. If I had just this, that would be a false statement because 9 is not less than 9. But as soon as I put the or equal to underneath it, that is now a true statement. Same thing the other way. 9 is greater than or equal to 2 because 9 is greater than 2. 2 is greater than or equal to 2 because 2 is equal to 2. Same thing. If I just had 2 is greater than 2, that's false. But if I add the or equal to underneath it, it is now a true statement. All right. Moving on to absolute value. All right. Now, absolute value. People sometimes get this mixed up and they think it makes a number its opposite, but that's not true. Absolute value, denoted by the straight lines. You put lines around what you want the absolute value of. All right. Is the distance from 0 on the number line. So if I have the absolute value of 4 and I make a number line, there's 0, 1, 2, 3, 4. That means absolute value means how far is that number from 0 on the number line? Well, if I go from there to there, all right, that is 4 units. So the absolute value of 4 is 4. Now, if I want to know what's the absolute value of -4, well, if I draw another number line, this time I put 0 over here, -1, -2, -3, -4. I want to know the distance. How far is -4 from 0? Well, we measure distances always with positive numbers, right? If you drive from Murfreesboro to Nashville, that's about 30 miles. Well, if you drove backwards, that's not going to mean you drove -30 miles. You still drove 30 miles to get to Nashville. Well, here, this distance, if I was using a measuring tapes don't measure negative numbers. It's always a positive number. This is 4 units, 1, 2, 3, 4 units from 0. So absolute value means the distance from 0. So -4 is 4 units from 0. So the absolute value of -4 is 4. The absolute value of 4 is 4. All right. Let me show you if I can figure out how to get out of this for a second. Let me show you on these calculators, these TI-83s. Now, the other scientific calculators does not do absolute value, but these TI-84s do. And the way we get there is we hit math, and then notice this comes up, and then under the number, so I arrow over once, and there ABS is absolute value. So I can just highlight it and hit enter, and notice it puts the 2 lines there. And if I do -4, get out of that, I hit enter, notice it gives me 4. Math, arrow over, absolute value of 4 is 4. Okay, so that's how you can do absolute value on these calculators. Let's go back to this. So, absolute value. All right. So here, find the absolute value. How far is -3 from 0? Well, it is 3 units. All right. 5 is 5 units from 0, and 0 is 0 units from 0. All right. So it basically, the absolute value always gives you a positive result because it's a distance. Distances are measured in positive numbers. All right. Now, I'm not going to go through all this. Addition of integers, we know how to add. We can get help from a calculator if we're adding and subtracting positive and negative numbers. Additive inverse have the same absolute value but lie opposite sides of 0. And all they're saying there is if you add the opposites together. 18 and negative 18, it adds to 0. Negative 7 plus 7 is equal to 0. Anytime you add a number and its opposite, remember opposites are one's positive, one's negative of the same number, it always adds to 0. Additive inverse is what that's called. Subtraction, the one thing I will say about subtraction is any subtraction problem can be written as an addition problem. A minus B is the exact same thing as plus a negative B. All right. However, most of the time we just leave it as subtraction. Okay. And if we're using a calculator, we can write it either way. The one area where we do need to make sure is especially if we're doing it by hand. Now, if you're punching in the calculator, it doesn't really matter. But anytime we have minus and negative, and we start talking about algebra and variables where we can't punch it in the calculator, it's very important that anytime we have minus and negative, right, it's always adding the opposite, right? Subtracting B is the same thing as adding the opposite of B. So we would, anytime we have minus and negative, that needs to be changed to plus a positive, and it would just be 4 plus 6 there. All right, which we know is 10. So that's the one case there that I would change it. Up here, if it was a minus, I would probably just leave it as a minus. All right, so all of these you could punch in the calculator. Like I said, minus and negative, I'm going to always change that to plus a positive. 17 plus 11 we know is 28. Right there. Negative 18 minus negative 5, I'm going to change that to plus and positive. Negative 18 plus 5. Now we're just using our addition rules. Use your calculator. Whatever. Now, if you do have a calculator, negative 18 minus negative 5 is, you can punch that right in the calculator. And let's look at that. Negative 18 minus negative 5. Notice if I clear this out and I say, what was that? Negative 18 minus negative 5. I get negative 13. Now, most of the time, we would like to go ahead and put that negative number in parentheses there so we don't get minuses and negatives mixed up. But notice this is going to give me the same thing. And then the same thing if I had changed it to plus a positive, plus 5, I get negative 13 every time. So if you're using a calculator, as long as you're putting it in correct, you're not going to have an issue. All right, so no reason to go through that very much. Multiplication of integers. It is helpful to remember, and we're not going to talk about repeated addition. Well, let's go right back here to multiplication real quick. This is sort of separate from here. It is helpful to remember if you multiply two positive numbers together, you're always going to end up with a positive number. If we multiply two negative numbers together, we're always going to end up with a positive number, right? If we multiply a positive times a negative, that's when we get a negative answer, whether it's the first number negative or the second number negative. So that is helpful to remember. That's the same thing with division. You divide two positives, you get a positive. You divide two negatives, you get a positive. You divide two negatives, you get a positive. You divide a positive and a negative, you get a negative. You divide a negative and a positive, you get a negative. All right, so remember that. Looks like we're going to talk about exponential notation. No, we're just going to talk about exponents real quick. Now, this is something that's very important. Whoa, I don't know where that came from. All right, here we go. All right, here's something that's very important, especially with the use of calculators. All right, is we have to remember that these two statements right here, negative 6 squared and negative 6 squared, are two totally different things. All right. In parentheses, if I'm wanting to square negative 6, I have to put the negative in parentheses, and then that's going to be negative 6 times negative 6, which is a positive 36. This one, the negative is not being squared because it is not in parentheses. Only the 6 is being squared. So essentially what I have is the negative of 6 times 6. 6 times 6, 36, and that's it, which is negative 36. It is very important when you're using a calculator that you are specific on that, because notice, If I type in -6 squared, it is only going to square the 6, and I'm going to get -36. If I want to actually square the number -6, I have got to put it in parentheses. All right. This is one mistake that happens over and over and over again, is you get in a hurry and you don't use your parentheses. All right. Now, if I was just working that out by hand and not using a calculator, and I put -6 squared without a parentheses, and I knew what in my mind what I was talking about, I wouldn't have an issue. But if we're using calculators, it is very important that you use that negative. Now, these right here, -5 cubed and -4 to the 4th power. Let's talk about on the calculator how we put those in. And what were they? -5 to the 3rd and -2 to the 4th. So if I want to put this in the calculator, I'm going to put -5 to the, forgot my negative. -5 to the 3rd. One way to do it is to hit the, where am I? Oh, the little caret button. All right. If I hit the little caret there, I can raise it to whatever power, to the 3rd. Hit enter. -125. -4 to the 4th. Hit the little caret button. And there we go. Okay. So we can raise anything to any power using the caret button. If I wanted to do squared, I could still do squared. I don't have to hit. It's just this is the little shortcut button over there. All right. So there shouldn't be any issues. Easy section here. Division. All right. Do remember that if you have a fraction, that is the exact same thing as writing it as it means division. A fraction means division. -12 divided by 4 is the same thing as -12 over 4. It's going to give you -3 either way. All right. The nice thing about these calculators is they'll simplify all these fractions for you. The other nice thing about calculators is they do the order of operations for you. So if you remember what order of operations are, they're the order. If I have several different arithmetic things in a mathematical statement, 3 plus 4 times 3 minus 6 divided by 2. All right. It tells me the order in which I have to do these things. All right. The thing I had always remembered growing up was please excuse my dear Aunt Sally. P stands for parentheses. You have to do anything that's in all operations that are within grouping symbols or parentheses. If you see brackets, brackets are the same thing as a parentheses. All right. Everything, all the operations inside the parentheses have to be finished before you move outside the parentheses. E stands for exponents. You have to evaluate all exponential expressions. So if I say that's 2 squared, okay. So notice here, there's a set of parentheses, but there's no operations in it. So then I would go to exponents. So I'd have to do this. Then after you do all exponents, you do all multiplication and division. Multiplication and division is equal. So if you have a multiplication and division in a problem, you go from left to right. So here's a multiplication, here's a division. So I would do this multiplication first, then I would go do this division. And then the last thing is addition and subtraction. Addition and subtraction are equal. You work from left to right. So once I do all that, I would do this addition before I did this subtraction. So if I was actually working this problem right here, I would do this first. So this would be 3 plus 4 times 3 minus 6 divided by 4, because 2 squared is 4. Then I would do that multiplication, 3 plus 12 minus 6 divided by 4. And then I would do 6 divided by 4, which is just going to be 3 plus 12 minus, and it's going to create a fraction, 3 halves. All right, then I would do this addition first. I would say 15 minus 3 halves. And then 15 minus 3 halves, I believe, is 13 and a half. All right. Now, the nice thing about these calculators, let's see if I can remember this in my head as I go to this calculator, is I can punch it right in the calculator. So I think I had 3 plus 4 times, I'm not going to be able to remember. I'm going to have to look at times 3 minus 6 divided by 2 squared. All right. The nice thing about these calculators, this calculator or the smaller calculator we have in class, or that you have, most calculators that you have. Now, the one on your phone, it's a little bit more different. Basically, it's any of these calculators that will let you type in the whole equation or the whole mathematical statement before you hit enter. Will do order of operations, and that's not correct because I hit multiplication instead of division. So it should have been 3 plus 4 times 3 minus 6 divided by 2 squared, and this should give me the answer. I had 13.5. I wanted to change that to a fraction, 3 there, 27 over 2. We'll change it to a mixed number. Yes, 3 again there, 13 and a half. All right. So these calculators will take care of the order of operations for you. But let's step through a few problems where I don't just punch it in a calculator so we see. All right, this one. All right, so please excuse my dear Aunt Sally. No parentheses. Exponents next are here and here. So I'm going to do 6 squared, which is 36, minus 24, divided by 2 squared is 4, times 3 plus 1. After exponents, multiplication and division from left to right. So there's a division here and a multiplication. So I'm going to go 36 minus 24. Nope, hold up. We're going to go ahead and divide. 24 divided by 4 is 6. So that's going to be minus 6 times 3 plus 1. Then 36. 6 times 3 is 18. So minus 18 plus 1. Addition, subtraction left to right. So I'm going to go 36 minus 18, which is 18 plus 1. End up with 19. Okay, that's how we would step through it by our order of operations. See what we have next. All right, so we do have a parenthesis, so this one's a little bit different. Right, we have to do the operations inside the parentheses first. And then within the parentheses, you got to follow your order of operations too. So inside the parentheses, before I subtract, I got to go multiply. So this is going to be 4 plus 6 minus 6 squared plus 16. Then that's going to be 4 plus, that is going to be 0 squared plus 16. Now I go back, I've got rid of my parentheses, exponents. So I got to do 0 to the second power, which is 0. And then I've got two additions. 4 plus 0 is 4 plus 16 equals 20. So that all simplifies down to 20. Once again, this could be punched right in the calculator and it's going to spit out the answer for you. All right, and that is it. A very simple lesson, I do believe. A lot of calculator activities. So we are done. See you later. And I've got to figure out how to turn this off.